also record the video. So this question 8 is not hard. It's a little bit conceptual. So they ask, explain why the equation, and the equation is bracket sine x minus 2 close bracket, and then bracket cos x plus 2 close bracket is equal to 0, has no solution. So if you want to solve, if I give you such an equation, and if you want to solve it, you basically have to say, okay, so either sine x minus 2 is equal to 0, right? But that means sine x equal to 2. But we know that sine x is always between
-1 to 1.
-1 and 1. So it cannot be 2. So here there is no answer. And the same thing with cosine. So when you want to do like cosine of x plus 2 equal to 0, that means cosine of x must be -2. But again, cosine is always between -1 and 1. So cosine of x equal to -2 has no answer. So the whole equation does not have any answer, no solutions. Is that clear for everyone?
Yeah, it's easy. All right. But I said it's not in the range. Is that correct?
Yeah. That's right. So.
Cool.
Okay. So how about question 7? Question 7 is okay.
Question 7, I think the hardest is B.
Okay, part B. Okay, I will do it. So, okay, so first do question 7B. So 7B, cosine of 3 pi half minus x. Sorry, 2 pi over 4 minus x minus sine of 3 pi over 4 plus x. So here what you need to do is just to use these identities for like cosine of a minus b is equal to cosine of a cosine of b plus sine a times sine b, and sine of a plus b is just sine of a cosine of b plus what? Cosine of a sine of b. So let's do it, apply it here. So here a is equal to 3 pi half, 3 pi over 4, sorry. So this is a, and this is b, right? So this guy is equal to what? It is equal to cosine of 3 pi over 4 times cosine of, so the only thing, so b is basically x, not minus x, because here we have, you know what I mean. Okay, so it's cosine of 3 pi over 4 times cosine of x plus sine of 3 pi over 4 times sine of x, and then minus, now it comes to sine, minus sine of 3 pi over 4 times cosine of x plus sine of x times cosine of times cosine of 3 pi over 4, right? So, but what is cosine of 3 pi over 4? Cosine of 3 pi over 4 is minus
1 over square root 2.
1 over, which is square root 2 over 2. And sine of 3 pi over 4 is just square root 2 over 2. That's it. So you just plug in the numbers. So this is equal to minus square root 2 over 2 times cosine x plus square root 2 over 2 times sine x, and then minus square root 2 over 2 times cosine x, and then minus square root 2 over 2 times sine x. So this is equal to, so you have 2 square root 2 over 2. So you get minus square root 2 cosine x plus square root 2 which is equal to minus the square root 2. Okay. Any question? All right. Let's go to question 6. Also, I want to do question 6 part B. Question 6 part B. So that is find the domain of f of x equal to a square root of 2 sine x minus 1. So here we have 2 sine x minus 1. Because it's inside the square root, this has to be greater than or equal to 0. So that means sine x greater than or equal to 1. So sine x is greater than or equal to 1/2. Now, here, there are different ways to do it. One way is to look at the graph. Just simply look at the graph of sine. So the graph of sine, so here, for example, you have, so at what point sine is equal to 1/2? At what point sine of x equal to 1/2? Sine of what angle is 1/2? Pi over?
Hmm.
Pi over 6. And then at pi over 4, pi over 2, it's 1. And then again at, you have 7 pi over 6. sorry, 5/6 is again 1/2, and then at pi it's 0. So imagine this is the maximum, which is pi half. So it goes up and then down. And then it goes like this. Okay. So at these 2 points, sine is 1/2. So one is this. Sorry. And one is this. Give me a second. Okay. So here and here, sine is 1/2, which is pi/6 and 5/6. Okay. Is this picture clear? But you want sine be greater than pi/2, right? Greater than pi/2 means here, right?
Patterns.
Is that clear? So greater than pi, sorry, greater than 1/2. So that means x has to be x has to lie between pi/6 and 5/6. Right? Okay, but the only thing, so that's it. That's the key. That's the key part. But there is a tricky part, and that is this repeats in every 2k pi, because the period is 2 pi. So not only x is between pi/6 and 5/6, but also x between 2 pi plus pi/6 and 2 pi plus 5/6, right? So what I mean is, so you can have, okay, so simply, first of all, you can have x between pi/6 and 5/6. But you could also have x between 2 pi plus pi/6 and 2 pi plus 5/6. And so on. 4 pi, you can add 4 pi. And in general, you can have x between 2k pi plus 5/6 and 2k pi plus pi/6. Okay, is that clear for you guys? So that's the domain. And here, k is any integer. Okay, now let's go to part C. I mean, part C, comparing to this, part C is easier because f of x is 1 plus x over 1 plus sine x. Again, here you have a denominator, you have a fraction. Whenever you have a fraction, you have to take care of the denominator. So the restriction, the only restriction is that 1 plus sine x shouldn't be 0. So you have to solve this equation and see for what x 1 plus sine x is 0, and then you remove those x's, right? So that means sine x is equal to minus 1, which is sine of 3 pi half. Okay, but it's not only 3 pi half, but 2k pi plus pi half. So x is so you basically remove this from the domain. So the domain would be everything but these guys. So the domain of f is the set of all real numbers, but does it make sense? Is that clear for everyone? Okay, now let's jump to last one, question 5. So we want to draw the graph of y equal to pi plus 3 times arctan. Okay, first of all, guys, the arctan, so arctangent is between, it's not equal, it's between minus pi half and pi half. And these two guys, y equal to minus pi half and y equal to pi half, these are the horizontal asymptotes. So these are horizontal asymptotes. Right? So if you want to draw the graph of just arctan, so you basically have two horizontal asymptotes. One is y equal to pi half, and one is y equal to minus pi half. And then the graph is just, you know, it's like this. Now, when you multiply it by 3, So 3 times arctan of x. So it's between 3 pi half and minus 3 pi half. You just multiply everything by 3. So in this picture. So that means if this is pi half and minus pi half, when you multiply it by 3, you get a new picture. Let me move it a little bit up. Okay, so you just multiply this horizontal asymptote by 3. So that means you get 3 pi half instead of pi half and minus 3 pi half. So that is 3 pi half and minus 3 pi half. And the picture is just right? It's just a vertical stretch. And then finally, you just have to add pi plus this. But that's a vertical transformation again. Upward or downward? Would it be upward or downward? When you add pi, when you add a number to y, you move it upward, right? So let me just, oh, sorry, copy this. Okay. So you just move it upward. So here, y is between, so 3 times arctan is between 3 minus 3 pi half and 3 pi half. When you add pi, 3 arctan of x plus pi would be between, what is pi plus 3 pi half? Pi plus 3 pi half is 5 times pi half. And pi plus minus 3 pi half is minus pi half. So it's basically just a horizontal, a vertical transformation, right? So it's pretty much the same thing, except that I will tell you what will change. So here. So in the y-axis, the horizontal asymptotes are 5 pi half, right? So this is 5 pi half. And the the lower one would be just minus pi half. So this, and this, imagine, is the y-axis, right? Now, what is this point? So what is the y-intercept? So for this, the original y, I mean, the 3 times arctan, so you have 0, 0. So when you add pi, when you move it pi upward, so here you get, this point is just pi, y is equal to pi. And that's it. So the two horizontal asymptotes are minus pi half and 5 pi half. So this is y equal to minus pi half and y equal to 5 times pi half. These are the two horizontal asymptotes. And that's the graph. And the y-intercept, which is an important point for the graph, is just the point pi. Because when x equal to 0, then arctangent would be 0, and then you add pi, you get pi. Is the picture clear? So I want to discuss the new concept, and that is the rate of change. It's extremely important. So rate of change. So what is the rate of change? A super important physical example of rate of change is the velocity. Velocity, or the speed, is the rate of change in the position. So it's the rate of change in the distance, right? So if you have a car and you imagine that in 1 hour, the car goes like, say, 100 kilometers in 1 hour, or say 2 hours. If in 2 hours, the car travels 100 kilometers, what is the rate of change in the position or the distance? So that means, so in this example, so if you travel 100 kilometers in 1 hour, in 2 hours, so the rate of change of distance or position would be 100 over 2 kilometers per hour, which is 500. So that means basically the average speed of the car is 50. Sorry, not 500. It's 50 kilometers per hour. And we can apply the same concept. Actually, we have the same concept for functions. And that is, so you have a function. And by the way, we have 2 types of rate of change. One is the average rate of change. And the other one is the instantaneous rate of change. And I will discuss each of them. So the average rate of change is simple. So you have a function. So let me draw, just say this function. And imagine that the value of the function at this point. So we look at 2 points. One point is, for example, this point, I call it, maybe it's -2. And another point, this point, let's say this is 6. And the value of the function at each point, so here I have maybe -1, and here is 5. Okay. So you have 2 points. One point is -2 and -1 on the graph. Another point is 6 and 5. So the average rate of change, so for briefly, we just say average rate of change, AROC, is defined to be, so if you have any 2 points like x1 and x2, is f of x2 minus f of x1. So this is the change in the y values divided by the change in the x values. So that is the general definition. So it is the rate of change of y values with respect to x values. So for this particular example, it's equal to, so you have 2 points, x -2 and x6. So f of 6, so this is equal to f of 6 minus f of -2 divided by 6 minus -2. Now, what is f of 6? In this picture? This graph is the graph of y equal to f of x. What is f of 6? It's 5. So it's equal to 5 minus, what is f of -2? Is -1 divided by 6 minus -2. So this would be equal to 6 divided by 8, which is equal to 3/4. So that is the average rate of change. Okay. We also sometimes call this delta y divided by delta x. The symbol delta means usually the difference, the change or the difference. So the change in y divided by the change in x, delta y divided by delta x. So it's very common to use this symbol, delta y divided by delta x. Okay. So let me just give you another example. So if I give you a function like f of x, imagine it's equal to 1 plus 2x over x cubed minus x cubed minus x plus 5. So, and I want you to find the average rate of change. Find the average rate of change over the interval . What interval? So let's say 1 and 2. That means these are two values of x. So here means like x equal to 1 and x equal to 2. Okay, or you can say x1 equal to 1, x2 equal to 2. So the average, we know that the average rate of change, as I said, is equal to delta y divided by delta x. But here you have to find the y values for each of these points. What is the y value for x equal to 2? So that is f of 2 minus f of 1 over 2 minus 1. So what is f of 2? What is f of 2? F of 2, so you just use this formula. So f of 2 is equal to 5 over 11. And f of 1 would be equal to 3 over 5. So this would be 5 over 11 minus 3 over 5 divided by 2 minus 1 is just 1. So this would be equal to, so 5 over 11 is 25 minus 33 over 55, right? Which is equal to, what is 25 minus 33? Minus. Right? So that is the average rate of change over this interval from x equal to 1 to x equal to 2. And I also want to tell you another thing. So the geometric meaning for the average rate of change is just the slope of the line that joins these 2 points. So here you have a line usually call this the secant line. Okay. So this average rate of change that we found in this example, that is basically 3 over 4. 3 over 4 is the slope of this line. So if I call this point, oh, sorry. if I call this point P, for example, and this point Q, so 3/4 is just the slope of the line PQ. The slope of PQ is just 3/4. So the average, so the important lesson here is that the average rate of change between 2 points is just the slope of the line that joins these 2 points together. This line segment. So this is the line PQ. Okay. So if you have a function that is constant, what is the average rate of change between any 2 points? If you have a function whose value is constant. What is the average rate of change for any 2 points? Is 0. Because if a function is constant, the y value doesn't change. So the change, so delta y is always 0. So no matter what delta x is, so the average rate of change would be 0. Okay? Okay, guys. So that is our lesson for today.